Existing contactless manipulation techniques are limited, either by their lack of selectivity and/or the type and size of particles which can be manipulated, and/or the range of forces which can be applied to these objects. They are also limited for biological manipulation by side effects such as overheating or phototoxicity. Acoustweezers technology is simply made of spiraling electrodes sputtered at the surface of a piezoelectric substrate, which are put into contact with the microscopic slide on top of which the manipulations are performed. The technology can be integrated in any existing microscope. The operator chooses the tweezers depending on the size and type of particle that he wants to manipulate, puts a drop of liquid on top of the tweezer, and the tweezer is then automatically put into contact with the microscope slide. The operator places a microscope slide on the stage of the microscope, spreads a drop containing the suspension on top of the slide, and covers it with a PDMS chamber slide. The operator selects the electrical power depending on the force that he wants to apply. Now he can catch any particle by aligning the center of the trap with the particle and then turning on the device and moving it simply by using the microscope stage. Many benefits are possible. The manipulation is contactless and non-invasive and does not interfere with the biological process, thus limiting alteration of the particle cell. The MEMS is highly compact and can be easily integrated in existing systems: microscope, lens, lab-on-a-chip. The system can manipulate particles ranging from 1 mm to 100 nanometers. The device production is simple, cheap, and compatible with current requirements. No pre-tagging is required for the manipulation. The MEMS is printed on a transparent material, enabling simultaneous manipulation and visualization. The trapping process is compatible with a large range of materials, including glass and PMMA.